So part 3, we're going to have a slope from a sketch. So let's say, for example, this is 2, and this is 9, and this is 1, and this is 5. And I've made kind of a partial line over here. So notice it's not exactly to scale. This distance is 4, that distance is longer. But the point is, this point started at 2, ended at 9. This point is at 1, we ended at 5. So how do we figure out the slope of this? So what we do is we're going to write. So before when we had these things over here, I gave you the vertical and the horizontal. What we're going to do now is we're going to actually draw them in. So the horizontal is going to be like this, and the vertical is going to be like this. And the vertical and the horizontal are, of course, 90 degrees away from each other. And here's our slope. So we have to figure out our rise. Let's do the run first, actually. So the run, we started at 2 and we went to 9. So we ran for 7. And if you could see that at 7, that's great. If you can't see it at 7, the mathematically way to do it would be to subtract the numbers. So we ended up at 9. We started at 2. So the run is 7. Similarly, the rise, we started at 1 and went up to 5. So you could kind of in your head figure out that we went up 4. But if you weren't sure about that, you could say that we ended at 5, we started at 1. So the difference, the amount we went up, is 4. And then, of course, we have our slope. So our slope is the rise over the run. The rise is 4. The run is 7. And the slope is 4 over 7. Let's do another one of those. So there's nothing special with this one, so you could probably pause the video and try to do it yourself. I'm going to plow ahead, assuming that you have paused the video. So that goes like there, that goes like there. And now the rise. So the rise is going to be, we went 8 minus 3, which is, oh, that's the run actually, sorry. The run is going to be 8 minus 3. We went from there to there, so we ran 5. The rise actually will be, we started at 2 and we went up to 17, so that's going to be 15. So the slope is going to be rise over run, which is going to be 15 over 5. And in this case, of course, we have to reduce it. 15 over 5 is 3 over 1, which is just 3. So the slope of this line over here is positive 3. We're going to do something a little bit different now. So what's different around this one is, of course, that it is going down instead of going up. So I'm going to make my vertical and horizontal lines. So I can imagine this. This is a right angle. Now, remember, we're going always from left to right. So in this case, we're going down. So the run is nothing special. The run is 8 minus 5. We ran 3. The rise here, though, is special. So one way to look at it is that we went from 9 to 4. We went down 5. If you wanted to do it in kind of a mathy way, we ended up at 4. We started at 9. And 4 minus 9 is actually negative 5. So we do get that negative in regardless. So common sense, because it's going down, or mathematically because we end up lower than where we started. So the slope is rise over run, which in this case is going to be negative 5 over 3. Now, sometimes the sketches won't be that pretty. What you might actually have is you may have a grid. So let's say you have a grid. I possibly should have done this on graph paper. Okay, so and so we'll say that this is kind of our y-axis, and this is our x-axis. We'll have a scale, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We'll go like this. Hopefully you have a better ruler than I do. This one's not a star. So let's say I said find the slope of this line. So I haven't given you points. What you have to do is that you have to figure out points. Now, you may look at this one over here, but that's not a good point. So we know that the x value is 0, but we don't know what the y is. Similarly, something over here, that's also a bad point because we know that it's 2 on the x, but we don't know what it is on the y. This one we know what it is on the y, but we don't know what it is on the x. So what we're looking for is we're looking for places where the line, the green line, crosses the grid. So for example here, it crosses the grid over here, and we know it's 1 on the x, 2 on the y. 1 on the horizontal, 2 on the vertical. Then we look, no, that's not good, not good, not good, not good. Oh, that's at another intersection. And there we go. So we're going to have to find the 2 points. This was not a good point, by the way. So we found 2 points that were on the intersections, and then we kind of make our triangle. So now, the rise, so we either went from 2 to 4, it could be 4 minus 2, or you could count. Make sure you don't count points, you count spaces. So it went up 1, 2. So the rise is 2. The run is 1, 2, 3, 4. Or you could say you went from 5 to 1. So 5 minus 1 is 4. And then the slope here would be rise over run, which would be 2 over 4, which shrinks down to 1 over 2. So the slope in this case is 1 over 2.